Welcome to the Explainer Focus Learners. Today we are demystifying cloud computing for digital archiving. You know, we hear the term the cloud thrown around constantly when we're talking about digitization and digital repositories. But to truly preserve our history, we need to know exactly how it functions under the hood. So, let's get into it. Here's a quick look at our roadmap for today. We'll start by demystifying the internet, then defining the cloud, exploring cloud models and services, weighing archival storage pros and cons, reading the fine print, and finally, peering into the future. Alright, Section 1. Demystifying the Internet, the foundation of the cloud. Before we can even think about storing our precious digital archives in the cloud, we really have to ask ourselves, what exactly is the Internet? I mean, we use it every single day, right? Whether we're pulling up a map, sending an email, or researching catalog records. But that information doesn't just magically appear on your screen out of the ether. How does it actually reach your computer? Where is it coming from? Well, the crucial point here is that the internet isn't magic. It's actually a massive, completely physical relay system of cables and routers connecting computers globally. Think about it like this. If you connect a few computers in your archival office, you have a local area network or a LAN. Connect them across a whole city and it's a metropolitan area network. The internet, it's just a wide area network, a WAN, scaled up to span the entire Earth. It relies heavily on physical infrastructure, like the massive fiber optic cables owned by major backbone companies, to transmit information rapidly from a server straight to your client computer. And this is a great way to illustrate the difference between two terms we constantly mix up. The internet is the global series of physical connections and cables. So, think of it as the physical roads. The World Wide Web, on the other hand, consists of the web pages and content accessed through those connections. Those are the delivery trucks using the roads. The web makes accessing the internet intuitive using things like URLs and IP addresses, but the internet can exist perfectly fine without the web. Let's move right along to Section 2. Defining the cloud. Not so mystical after all. Building on that physical foundation, let's look at the cloud itself. The very word cloud makes it sound like your data is just floating around up there in the atmosphere, waiting to be plucked from the sky. But the reality is much more grounded. Your digital archives are just sitting on someone else's physical server. That's it. The data stored in the cloud typically resides on physical hard drives or increasingly solid-state drives, simply because they're faster and eat up less electricity. Now, because the cloud can be a bit nebulous to pin down, the National Institute of Standards and Technology, or NIST, defines it using these specific features. On-demand self-service means no human interaction is needed to grab your data. Broad network access means you can get to it from your phone, tablet, or desktop. But as an archive, you're really going to love rapid elasticity and measured service. Look, if you buy a 1 terabyte hard drive but only use 500 gigs, you've wasted money, right? In the cloud, you pay for exactly what you use. The service effortlessly scales up processing power in the morning when you're running heavy photo editing software and scales it right back down in the afternoon. Okay, on to Section 3, Cloud Models and Services, How We Share Servers. There absolutely isn't a one-size-fits-all approach here. As information professionals, we have 4 primary models to choose from, totally depending on our organization's specific security and collaboration needs. Those are public, private, community, and hybrid. A public cloud, like Amazon Web Services, is formed by servers available to anyone who subscribes. It's incredibly cost-effective, but you are sharing hardware with total strangers. A private cloud, however, is designed for one specific organization. So, while a public cloud is super easy to access, a private cloud is like owning your own detached building. It keeps your digital collections highly secure and dodges many of the legal headaches we'll talk about in a minute. The catch: it's typically only practical for very large, well-funded archives. Now, a fantastic middle ground is the community cloud. Let's say your archive teams up with other local archives or universities to share server costs. You're building a highly efficient community cloud. You all share similar needs and you have a say in how security is maintained. Finally, a hybrid cloud is exactly what it sounds like. A custom combination of multiple cloud types, giving you a tailored fit for more complex archival setups. Beyond the structure itself, we have to look at what exactly we're renting. It helps to think of infrastructure as a service, or IaaS, as renting the empty land and the physical hardware. Platform as a service, or PaaS, is like renting the construction tools to build your own custom archival software. And software as a service, SaaS, is like renting the fully furnished house. Things like Google Docs or Dropbox are SaaS. For an archive, SaaS is a massive time saver. Why? Because you don't have to install and update a digital collection database on every single computer in your building. Everyone just accesses the same updated version through the cloud. This brings us to section 4, archival storage pros and cons, weighing the risks. Cloud storage is truly a double-edged sword for a digital repository. On one hand, you save an incredible amount of money on electricity, hardware, and physical maintenance. But on the other hand, you introduce some seriously complex new risks around data ownership and constant internet reliance. It really comes down to balancing these factors. The pros are undeniable, right? You get automatic remote backups in different geographical locations, which completely protects you from a local disaster like a fire or flood. Plus, you get a massive boost to processing power without buying new computers. But the cons are pretty severe. Strict reliance on internet connectivity means if your network drops, your archive's work literally grinds to a halt. Furthermore, passing your data through the internet introduces potential security hacks that simply wouldn't exist if the data was just sitting offline on a disconnected hard drive in your vault. And here is the most terrifying drawback for any archivist, the legal reality of data ownership. Back in 2012, the FBI actually took down the cloud storage company Mega Upload because some users were storing pirated films. The problem? Innocent users who were storing their files completely legally lost all their access too. No warning. It's exactly like police confiscating an entire physical storage building just because one single unit had contraband inside. All your redundancies and backups mean absolutely nothing if the government seizes the actual servers. So let's talk about that in section 5, reading the fine print, protecting your archive. Because of those stark legal realities, we absolutely must scrutinize every agreement we sign. When you purchase cloud storage, you don't actually own anything. You are just renting space. Think about this. If a provider like Dropbox or Facebook changes their terms of service overnight, which, by the way, Dropbox actually attempted to do in 2011 before public outcry reversed it, your archive's digital assets could suddenly legally belong to them. They might even reserve the right to scan and delete files they deem inappropriate without even consulting you. When you're reviewing a contract, one absolutely crucial thing to look for is the server location checkbox. Sure, check for subscription lengths, payment penalties, and backup guarantees. But the physical location of the server determines which country's laws apply to your data. A server located in another country subjects your archive's sensitive digital records to that specific country's legal jurisdiction. That is a massive consideration you've got to run by your legal counsel. Finally, let's look ahead. Section 6, the future, edge, fog, and ocean floors. So where is all this technology heading next to solve these current limitations? Well, cloud computing requires vast data centers, and those servers generate massive amounts of heat. Cooling them uses an unbelievable amount of electricity. Because of this, tech giants are creatively relocating them. There are actual plans to build large data centers in Norway just to utilize its naturally cool climate. Even wilder than that, Microsoft has literally been testing data centers sealed inside cylinders at the bottom of the ocean off the coast of Scotland to harness the water's natural cooling effects. How cool is that? We're also seeing a major shift in how data is processed to combat internet latency. Enter edge and fog computing. Instead of sending everything all the way across the globe to a centralized cloud server, these models process data locally on the device itself, that's the edge, or on a nearby node, the fog, before transmitting it. This dramatically saves bandwidth and time. It's absolutely vital for fast-moving technologies like smart cars that literally can't afford to wait for a server halfway across the world to tell them to hit the brakes. So, as an information professional, I want to leave you with this final thought. In an era of edge computing and ever-changing legal contracts, where do your most valuable digital possessions actually live? The cloud is incredibly convenient, offering amazing flexibility, processing power, and robust backups. But true preservation means always knowing exactly whose server holds your history, where it physically sits, and what your contract says about who actually owns it. Thanks for joining me on this Explainer Focus Learners. Keep exploring and keep preserving.